Picking up with Unit 2, Lesson 11, we're going to be doing example 4 in this video. Before we get to that, we have to talk about the key concept of a discontinuity point. So if we are looking at a rational function with a of x over b of x as our function, we have some factor x minus c, some number c. There is a discontinuity point at x equals c. The key point here is that x minus c has to be a factor of both of these functions. So if you are able to factor out some stuff in the numerator and the denominator and you get a factor that cancels, at this value that would be whatever value you plug in for x to make that thing equal 0, there's going to be a discontinuity point. So basically it's a hole in the graph at that value. So if you had a function that factored into x plus 2 times x plus 1 over x plus 1, you would just cancel the x plus 1s according to everything that we've done so far, and you'd just be left with x plus 2. So you would graph the line x plus 2, except for the fact that because there is a hole, because if you plug in -1 right here, you get this divided by 0. You can't take your original function and divide by 0, so that the function doesn't exist at that one value. There's a hole at that one value for that factor, the factor that you canceled out. So let's look at an example where we have a discontinuity point. So we have the function x squared minus 4 divided by x minus 2. And hopefully right off the bat you can recognize that this numerator is a difference of squares. It comes out to be x plus 2 times x minus 2. So if we write the numerator in the factored form, wow, can't draw straight lines with my mouse today, over x minus 2, you can see that the numerator and the denominator both have the x minus 2 factor. So this function is essentially just x plus 2, but you need to talk about the fact that x cannot equal this value that you would plug in this factor. See how these cancel, x minus 2 and x minus 2, they would cancel out. But what value would you plug in here to make this piece equal 0? Well, obviously that would be 2, because 2 minus 2 gives you 0, so x cannot equal the number 2. So the graph that you're going to make is just the line x plus 2, but when you get to the x value of 2, you need to put a hole in your graph. So let's see how they go about doing that. So they factored it, they got a hole at x equals 2, simplified to just x plus 2. Our graph then is the line x plus 2. When you get to the value x equals 2, there's a hole. This one's pretty simple and straightforward. So we're going to do a check your progress problem now. Which graph below is the graph of x squared minus 16 over x plus 4? So you want to factor the numerator, see what stuff you can cancel out, then figure out which graph has the correct hole. So pause the video when you have your answer, go on to the next screen. All right, our answer for check your progress number 4 is graph C. When you factor this numerator, you should simplify down to just the equation x minus 4, and you would have a hole, a discontinuity point at the number -4. X cannot equal -4. So notice here we are at -4. This number right here is 1, 2, 3, 4 to the left. If you had chosen A, you did 1, 2, 3, 4, you did 4 to the right. You would have said x cannot equal +4, but it's key that you have -4, because if you plugged in -4 here, -4 plus 4 would give you 0, and that would be dividing by 0. You can't do that, so that's why the discontinuity point is at -4. If you plugged in +4, you would have gotten 8, and you can obviously divide by 8. So that's why it's C instead of A. All right, we are finally at the end of Unit 2, Lesson 11 after 4 videos. I know this was a long lesson. There's a lot of explanation I felt like I had to do to make sure you guys understood all the graphs for this lesson and how to create them. All right, you can go ahead and get started on the work now for this lesson.